Alright, hello all. My name is Pletnyova. Today I'll be talking about caffeine. Now, we all know caffeine. Do we really? Do we know what it does to us in our bodies? We know we like it. We know how it makes us feel. Kinda. So let's dive deep, shall we? Into caffeine, our favorite psychoactive drug. Let's start with some background. Where is caffeine found? It's found in a lot of drinks. Energy drinks, coffee, tea, all of which people drink to make them feel energetic or awake. That comes from caffeine. If you can see the chart, I've got, Bang Energy, 300 milligrams per 16 ounces. Quite a lot for one drink. On the smaller side, we've got 12-ounce cup of Coke is 34 milligrams. Cup of green tea sits at the lowest at 28 milligrams per 8 ounces. Where does caffeine come from? It naturally occurs in about over 60 plants. Right here you can see that it's occurring in tea leaves. It can also be derived from the cacao bean from chocolate. There's also a little bit of caffeine in chocolate. And here we have the coffee bean. And now, what is caffeine chemically? Its chemical name is 1,3,7-trimethylxanthine. Now, let's break it down. Here I've got a methyl group, CH3, 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 trimethyl. That's where that comes from. There's 3 methyl groups attached to this xanthine, which is this structure with the nitrogens and the oxygens. Alright, why do we even drink caffeine? What are the effects, the perceived effects of caffeine really? So these effects take place all the way up to about 4 to 6 hours after you take in the caffeine. It's a stimulant, so it stimulates your central nervous system. And what this means is it makes you feel a lot more awake, a lot more energetic, a lot more motivated, a lot more productive, a lot more energetic. Similarly, cognitive performance and attentiveness increases. What this means is you can solve math problems a lot easier. Anything that requires a lot of higher cognitive functioning, caffeine really helps get the gears going on this. Now, it can't all be good, right? So there's got to be some downsides. What are the downsides? To start, if you drink a lot of caffeine, or if you don't, if you're particularly sensitive to caffeine, if you drink a lot or intake a lot, you can actually get a little bit of anxiety because you're, too stimulated and your heart's racing, which can all translate into anxiety. Lastly, insomnia can happen if you drink caffeine too late in the day. It will continue its stimulating effects and prevent you from feeling tired to go to sleep. It also increases your heart rate and your blood pressure. This is because initially caffeine is a vasoconstrictor, but we'll talk more about that. It also can lead to your hands shaking. As you can see this little cartoon over here, he's had a whole bunch of coffee, he's shaking. He looks like he's having a good time though. People that drink caffeine regularly, people that have built up a tolerance to caffeine, if they decide to skip a day of their routine without caffeine, they may end up going through what's called a withdrawal. And the most common withdrawal symptom for caffeine is headaches. Otherwise, caffeine is completely safe. Otherwise, let's go talk about by what mechanisms caffeine works. Let's talk about caffeine's journey through the body. So initially, you take your first sip of caffeine and it passes through your epithelial tissue. What this means is it goes straight, it doesn't have to be digested in your stomach first. It goes straight from when you put it in your mouth, the epithelial tissue in your mouth, in your throat, in your esophagus, in your stomach will just allow that caffeine to pass through directly into your bloodstream. It only takes about 45 minutes for about 99% of the caffeine to be absorbed. So in about an hour after ingestion, you'll feel its full effects. After then, it travels into your liver. It's metabolized by your liver, and it's broken down or metabolized into theophylline, theobromine, and paraxanthine. What isn't metabolized in your liver then travels up to your brain, where the caffeine is pretty chemically similar or structurally similar to adenosine. And what adenosine does is it makes you feel tired. It signals your body that it's time to rest, it's time to go to sleep. But instead of the adenosine binding to adenosine receptors in your brain, the caffeine actually steals their spot and binds in the adenosine receptors. And what this means, this is the caffeine masking your tiredness. You might still need the same amount of sleep, but you won't feel tired. You'll feel the alert and wakeful like we talked about earlier. Now, after the adenosine isn't able to bind to these adenosine receptors, what it does is it travels back through your body. This also increases your dopamine levels, which is where the motivation and productivity increase comes from. The leftover adenosine that's traveling along your bloodstream will signal to your adrenal glands that it's time to produce some adrenaline, and this also produces that alert, wakeful feeling. Caffeine is initially vasoconstrictor, as I said before. However, the liver metabolizes this caffeine into theophylline, theobromine, and paraxanthine, right? Theophylline actually relaxes smooth muscles. And so those contracted artery walls that caffeine caused, the theophylline actually comes back and undoes that. It relaxes the arterial walls and allows more blood to pass through. It actually also relaxes the muscles around your colon, which is why some people may feel the urge to go to the bathroom after having ingested caffeine. Additionally, caffeine is also diuretic, so it signals to your body that more liquid needs to leave your body than usual. Otherwise, theobromine, another product of caffeine's metabolization, it increases the amount of oxygen and nutrients that your brain can take in. And then after all this is done, the half-life of caffeine is about 4 to 6 hours. So at about 8 to 12 hours is when all the caffeine will pass through your system. Some people experience a crash at this time, and this is because all those free-flowing adenosine molecules now have their space back. They can bind in your brain again. Now, the time range on this is different for many different people. It depends on how sensitive you are genetically to caffeine, it depends on your tolerance, and it depends on other drug sensitivities, like grapefruit juice or nicotine. But the half-life is 4 to 6 hours. And so think about it. If you were to take in an afternoon cup of coffee at 2 o'clock, you've got 3, 4, 5, 6 hours until 6 p.m. minimum, but possibly 7, 8, until only half of that caffeine has left your body. You need to go to sleep soon. You've only got 1-2 hours left, but in 4 to 6 hours is when the rest of the caffeine will leave your system. So I hope you learned something, and maybe you'll reconsider your afternoon tea. I might not still, but that's just me. It's nice. Regardless, thank you for listening to my presentation. Here's a full list of my references from where I found all my material. Thank you very much. Goodbye.